Now we're ready to look at the general principle of inclusion and exclusion, where we have an arbitrary number of sets. In this case, I'm using the letter n for the number of sets that we're combining together by taking the union, and we want to find out how many things there are in the union when we combine them all together into the single set. And the formula looks like the ones we've had before in terms of we add the number in each set individually, then we subtract the number in each intersection of two of them at a time, then we add back in the intersection in any three of them at a time, and in this case where we have more than three sets, we'll actually have a sum of those, so it would be different possibilities. Then we have the next term will be a difference, and then an addition, and that repeats minus plus, minus plus, minus plus to the very last one, where there are n sets total, as we started off with it, and we count how many are in the intersection of all n of them all at once, and the sign that would go with that is minus 1 to the n plus 1, because whenever there are an odd number of sets that we're including here, the associated term has a plus sign, and whenever there are an even one, like 2 here, the associated sign is a minus. So in that pattern continuing, the parity would be difference. In other words, if n is odd, the power on the minus 1 would be even. If n is even, the power on the minus 1 to the n would be odd. So that's the formula that just extends it. And I think I will show you why this is true by doing a count of the number of elements on the two sides. Let me put it a different way. If I take an arbitrary thing out of the union, I want to make sure it's counted once on both sides. Okay? On the left-hand side, it would be counted once. So let's suppose if something x is in exactly m of the sets, let's see how many times it's counted. It is counted as follows. So I'm going to be drawing over this with a different color here, I think. So on the left-hand side, it's counted once. It's just one of the things in that union. Whereas on the right-hand side, if you look at the sum here, there are m of the sets that it's counted in. So it's counted in here m times. And now we have a minus here, and it's counted there minus, well, let's see, it's in exactly m of the sets. So how many ways will it be in a pair of them at a time to be in the intersection? Well, there are m choose 2 pair of sets that it will be in. So that's how many times it will be in an intersection of two of them. And in like fashion, it will be, with the plus here now, it will be an m choose 3 of the 3 of the sets all at once. There are m choose 3 ways to pick 3 of the sets out of the m in which the element lies. And that's how many ways it will be in those. And then it's minus plus out to minus 1 to the m plus 1. And this would be m choose m of the sets it lies in. Okay? We don't care what happens beyond that. It's not in any intersection of more than m of the sets, because it is in exactly m of those sets. Yeah? So that's what we get on that side. Now that looks a little confusing perhaps, but I'm going to do a little trickery on it. In particular, what I'm going to do is add a 1 and subtract a 1. So the way I'm going to do that is I'm going to add a 1 over here, and on this side over here I'm going to subtract a 1, and this is just all on the right-hand side. And now I'm going to rewrite those in the way that is more convenient. So this becomes, going back to the red that we were using, this becomes, I'm going to write that as minus m choose 0, and I'm going to write plus m choose 1 for m, minus m choose 2, etc. And this would be plus minus now. The next term is plus. I won't write it in there. All the way to minus 1 to the m plus 1, m choose m plus 1. Now this first part here is actually something we've looked at, but let me pull a minus out of that. Let me just write it this way. This is a plus 1 right here. Plus 1. Let me write it as summation m choose, let me use an r to distinguish it from the ijk we've already used in the formula above. R, where r goes from 0 up to m, and then I have a minus 1, and when the number here is even, I get a minus sign. When it's odd, I get a plus. So it's minus 1 to the r plus 1, like so. Plus. Sorry, I went back, just stuck with the blue there. That's okay, I guess. Let's go back to the red. And then I have the plus 1 on the end. Okay, that plus 1 right there. This guy right here, if I pull a minus 1 out, that's equal to minus summation m choose r minus 1 to the r plus 1. R goes from 0 to the m. Now, maybe you recognize this. We had a k when we did it. We did this in class. This thing is 0 because it is minus 1 plus a minus 1 raised to the m power plus 1, and that's just 0 using the binomial theorem, so we get 1. That 1 is good. It matches with that. That's a proof that the formula is true. So this proof maybe isn't something I would ask you about. It's for your benefit to see how it works out, but I do want to do an application of it.